Hey everyone, welcome back. In today's video, we are diving into an important concept in system design called back pressure. It's a mechanism used in data flow systems to prevent overwhelming components when dealing with varying workloads. Whether you are designing APIs, message driven systems, or streaming data pipelines, understanding back pressure is crucial for building resilient systems. Let's get started. So, what is exactly back pressure? It's a flow control mechanism used in systems to manage the rate of data production and consumption. When the consumer cannot process data fast enough, back pressure signals the producer to slow down or stop sending data until it can handle more. Imagine you have a system where a producer is generating data, let's say a web server handling HTTP requests, and a consumer like database that writes these requests to storage. If the producer generates requests faster than the database can handle, the system becomes overwhelmed and may crash or drop data. Back pressure prevent that from happening. Okay, without back pressure, when a consumer is overwhelmed, data can start to pile up in memory, causing slowdowns or even crashes. This happens because the producer keeps sending data at full speed, regardless of whether the consumer is ready. For example, in a video streaming service, the server could be streaming data faster than the client can buffer and display it. If there is no back pressure, this will eventually lead to buffer overflows, the poor user experience, like lagging or freezing. So, how back pressure work? Or how does back pressure work? It introduces a feedback loop where the consumer can signal the producer to slow down or pause sending more data. Once the consumer has caught up, it signals the producer to resume. Think of it like driving on highway. If there is a traffic jam ahead, cars slow down, and the cars behind them get signals to slow down as well. Once traffic clears, everyone speed up again. Back pressure works the same way, managing flow of data in real time. Okay, so back pressure has a lot of uses in real world. First, we need to talk about back pressure in APIs. Let me give it a color white. Back pressure is often used in APIs to manage incoming request loads. If a server is overwhelmed, it can respond with HTTP status code like 429, which is too many requests, to signal that the client should reduce the rate of requests or retry later. An example for that, for example, a rate limited API like Twitter might enforce back pressure by throttling clients who make too many requests in a short period. This helps maintain the performance of the API without dropping requests. Number two, we can talk about back pressure in streaming systems. So, in streaming systems like Apache, Kafka, or Apache Flink, back pressure ensures that when data processing slow down, upstream components reduce the rate of data being sent to downstream components. For instance, in a data pipeline where messages are produced at a high rate, back pressure ensures the processing system doesn't get overwhelmed by temporarily uh, halting the inflow of messages. Okay. The simplest approach to handling back pressure is buffering. A buffer holds data temporarily between the producer and the consumer, allowing the consumer to catch up. However, buffers have limited capacity, so they only offer short-term relief. In like an example for that, in message queue systems like RabbitMQ, messages are placed in a buffer until the consumer is ready to process them. But once the buffer is full, back pressure kicks in to prevent more messages from entering. Another technique is rate limiting, where the producer is limited to generating data at fixed rate. This ensures the consumer isn't overwhelmed by bursts of data. For example, a web server might use rate limiting to control how many requests are processed per second, ensuring that the backend database isn't flooded with too many requests at once. In model systems, reactive programming frameworks like reactive streams in Java or RxJS in JavaScript implement back pressure natively, and these systems data producers and consumers are linked with a mechanism that automatically adjusts data flow based on the capacity of the consumer. For example, a reactive stream can ensure that if a subscriber to a data source is slow, the stream adjusts the flow of data to match the subscriber's processing rate. Okay, while back pressure solves many problems, implementing it comes with its own challenges. First, latency. Reducing back pressure can increase latency as data may need to wait longer in buffers. Also, we have some complexity because adding back pressure mechanisms can increase system complexity, especially when dealing with multiple producers and consumers. Also, degrade performance because if not handled properly, back pressure can lead to reduced system throughput. A classic example is when a system's buffer become too full and the producer halts too often, leading to inefficient use of resources. This can result in poor user experience, especially in real-time applications. Okay. First, always set realistic limits on the amount of data that your system can handle. This involves knowing the maximum throughput of your consumers and ensuring that your producer don't exceed that limit. Another best practice is dynamic scaling. If a system is receiving more data than it can handle, dynamically scale up your consumers or processing power to handle the increased load. Finally, always monitor the health of your system and adjust back pressure thresholds in real time based on the system's performance. Tools like Datalog can help monitor metrics and trigger alerts when thresholds are reached. So, to wrap up, back pressure is a crucial concept for managing data flow in real time systems by controlling the rate at which data is produced and consumed. Back pressure helps avoid system overload, ensuring reliability and stability. Um, if you have any questions, or if you have encountered back pressure in your own projects, let me know in the comment section below. Thanks for watching this video, and I will see you in the next video.